Hi everyone, good evening to all. Today we are going to study about the question number 66. That is all about the planetary motion. So the very first thing here what we have to understand is what are the Kepler's laws of planetary motion. So there are three Kepler laws about the planetary motion. One is law of orbits that says all planets revolve in elliptical orbits around the sun, as sun is sun is at one of its foci. And second one is law of area. That means the planet position vector sweeps equal area in equal time, and it is also called as law of conservation of angular momentum. And the third one is law of periods. That is, square of the time period, time to complete one revolution, is directly proportional to cube of the semi-major axis. Now when you consider an elliptical path, it will be like this. Now this is called semi-major axis and this is called semi-minor axis. So this value is A, this value is B. Now there are two focus. Now sun will be at one of the foci. Now if you consider this is planet, now it moved from here to here in a time t1 and it moved from here to here in a time t2. Then first one says that all are elliptical path, means all planets revolve around the sun in an elliptical orbit with sun at one of its foci, one of the focus. Now, the second thing is when you consider in time t1 and t2, area equal if t1 equal to t2. So the area swept by the position is same when the time interval is same. And then we will say that for any particular elliptical path, for any particular elliptical path, the square of the time period is directly proportional to cube of the a cube, that is semi-major axis. And here it is also equal to dA by dt equal to remains constant. This is second law, where this will become L by 2m remains constant. That is angular momentum remains constant. Now angular momentum means mvr remains constant. So v1 r1 equal to v2 r2. And here comes V maximum R minimum equal to V minimum R maximum. So this is the relation between the speed and distance. Like when planet is here, then R is minimum, and when planet is here, now this is like R maximum. Now R minimum and R maximum, when you consider, R minimum is A minus AE and R maximum value is A plus AE, where E is called eccentricity of the ellipse. So they will mention that constant value in the question. Now The next thing what we have to understand is what is the orbital velocity of satellite or planet. So according to Newton gravitational law, now when you consider this is sun of mass m and there is a planet of mass m, and if it is revolving around it in a particular path, he said that is circular path. So according to Newton gravitational law, the all planets revolve around the sun in circular orbit under the effect of gravitational force, that is gmm by r square, and this is the one which provides the required centripetal force, so that mv square by r. Now v equal to under root gm by r. This is called orbital speed. Orbital speed of the planet, or when you consider satellite around a planet, the similar formula will come. Like here capital M is the one about which it is revolving. In case of sun planet, capital M is mass of sun. In case of planet and satellite, capital M is mass of planet. Who is revolving is not important. About whom it is revolving is important. So accordingly, we will take the equation for orbital velocity. So in a particular orbit, with what velocity a planet or satellite is revolving, that speed we call it as orbital speed or orbital velocity. Now, what is the total energy of satellite or planet? So when you consider, see, there is a path. Now this is capital M, this is small m revolving around it, like planet and sun or planet and satellite, whatever it is. There is one potential energy that is minus gmm by r, where r is the distance between their center of masses. And there is a kinetic energy that is half m v square, or you can also consider as v naught, because it is orbital velocity. So you can consider like v naught. So half m v naught square, if you substitute the value gmm by 2r, then the total energy will become k plus u, that is if you add both of them, minus gmm by 2r. So that the total energy, if you observe, it is equal to negative of kinetic energy and half of the potential energy. So this is the total energy of the satellite or planet. Now at any particular distance, g equal to gm by r square, so that gm equal to gr square. Now the total energy can be written as minus mgr by 2. So this is another formula in terms of small g. So like that you can understand what is the total energy of a satellite. Now another thing is, what is the escape velocity from the surface of a planet? So to escape a body from planet, give sufficient kinetic energy so that total energy will become zero. Like if this is the one planet of mass m, radius r, now a mass is kept at one point, then its potential energy is minus gmm by r and kinetic energy is 0. Now let kinetic energy given is k equal to half m v square, where v is the speed to escape it from the surface. So that now u plus k should become 0, then ve value you will get it as under root 2 gm by r. Now if particle moving in circular orbit closer to surface, then r approximately we will take it as capital R. Then v naught will become under root gm by r. ve will become under root 2 gm by r. That is root 2 times v naught. But this is the condition when height of the particle is very smaller. It is moving in circular orbit of less height. Means the path radius is almost equal to the radius of the planet. In that case, you can take a relation between orbital and escape velocity. Now, suppose if there is a planet of mass m, radius r, now the particle is at a height h, then to escape from a distance h from the surface, then the escape velocity will become under root 2 gm by r or under root 2 gm by r plus h, because now we are not throwing it from the surface, we are throwing at a particular distance or height h, so that the distance will become r plus h. So that way you have to understand. Now, so based on whatever are Kepler's laws and orbital speed and total energy of the planet or satellite or escape velocity of a particle from the planet, let's see few examples. Like the very first one is Jupiter has a mass 318 times that of Earth and its radius is 11.2 times the Earth's radius. So one is Jupiter has mass 318 times that of mass of Earth and radius is 11.2 times that of radius of Earth. And estimate the escape velocity of a body from Jupiter's surface, given that escape velocity from surface of Earth, that is root 2g me by re is 11.2 kilometer per second. Now escape velocity from the surface of Jupiter means 2g mass of Jupiter by radius of Jupiter equal to 2 into g into 318 mass of Earth by 11.2 radius of Earth. So that root of 318 by 11.2 times root of gme by re. So that it will become root of 318 by 11.2 times. This is nothing but the escape velocity from the surface of Earth, that is 11.2. So that you will get the 318 into 11.2 root of. So this way you need to calculate the escape velocity. In comparison they can ask, or direct they can ask. Like here in this question, they have asked the comparison between two different planets. And I said many times that comparison based question can come from any chapter. Now, a particle is projected from the surface of Earth with an initial speed of 4 km per second. Find the maximum height attained by the particle. See, a particle is projected from the surface of Earth. Now, this is Earth of mass m, radius capital R, from the surface at a height h. So, you are throwing with a speed v, so that it reaches a maximum height, something h. So that here speed will become 0. Let's take this speed is u. Now, let's take this point A, this point B. Now at A, the total energy is, one is kinetic energy half mu square plus potential energy minus gmm by r. Now at point B, the kinetic energy becomes 0. So the only energy is potential energy minus gmm by r plus h. Now find the maximum height they are asking. So the total energy remains same. So if you equate EB or EA equal to EB, then the equation will become half mu square minus gmm by r equal to minus gmm by r plus h, where m get cancelled. So that you can substitute in the equation, u value they have given. Now, so substitute the values, then you will get the answer. Now, the next question is, a particle is projected vertically upwards from the surface of Earth with a speed equal to 1/4 of the velocity, escape velocity. The speed is 1/4 of escape velocity. What is the maximum height attained by it? So again same concept, from the surface you are throwing with a speed so that it will go to some maximum height. Now here total energy EA, that is half mv square plus minus gmm by r. Now at this point the total energy will become only minus gmm by r plus h. H value we have to find. But here V value they have given as VE by 4, that is 1 by 4 times under root 2gm by r. Now you just try to substitute. So EA should be equal to what? EB. EA means half m. V square means 1 by 16 2gm by r minus gmm by r should be equal to the final energy is minus gmm by r plus h. So that 2 8s are 2 4s are. Now if you take gmm by r common, see 1 by 4 minus 1 equal to minus gmm by r plus h. So gmm get cancelled. So here I am writing, see like here 4 minus 3 by 4r equal to minus 1 by r plus h. Minus minus get cancelled. So 3r plus 3h equal to 4r. So that 3h equal to r. So h equal to r by 3. So to what maximum height it can reach is 1/3 of the radius of the planet. So this way conservation of energy you must be able to apply, so that then only you can solve the questions. What is the initial point? What is the initial kinetic energy, total energy, and what is the final? Then you have to equate both sum. Now, the next question is, a satellite circled around the Earth at a distance of 100 km. Determine its orbital speed. The radius of Earth is. So it is direct question. Under root gm by r, where m value they have not given, so you can take it as gr square. So v naught will become under root gr. G value given, r value given, where r equal to r plus h. That means r is 6400 plus 100. So r value will become 6500 kilometers. So just substitute. So v naught equal to under root g is 9.8, r is 6500 into 10 power 3. So then if you calculate it, you will get the answer. But here only thing is capital M they have not given, so that you have to convert the equation in terms of small g. That is what the main thing. Now one last and final question. An artificial satellite moving in a circular orbit around the Earth has a total kinetic plus potential energy E naught. Its potential energy and kinetic energy respectively are. See, an artificial satellite moving in a circular orbit around the Earth has a total kinetic plus potential energy E naught. Its potential energy and kinetic energy respectively. So total energy means kinetic energy plus potential energy. Also total energy means negative of kinetic energy, half of the potential energy. Now total energy they have given as E naught, and total energy is always negative. So the kinetic energy is equal to minus of E, that is minus of minus E naught plus E naught. So the kinetic energy is E naught, and potential energy is double that of total energy, that is minus 2 E naught. So E naught and minus 2 E naught. So potential energy is minus 2 E naught and kinetic energy is E naught. Always kinetic energy positive and potential energy negative. So this is how the questions will come based on the planetary motion. Sometimes they may give the questions based on the Kepler's laws, direct whatever formula we have taken, based on the conservation of angular momentum, like V maximum R minimum equal to V minimum R maximum. So just try to remember those formulas, like R maximum is A into 1 plus E, R minimum equal to A into 1 minus E. So solve these 5 questions which I have given as an assignment, so that you will get the idea like how to solve the questions based on this. So thank you all of you. We'll continue in the coming session with the next question. Thank you all.